We're going to finish up section 9.4, and the part where we were working on last time that we stopped in the middle of was the part on expected value. So if you remember, the idea of expected value was taking into consideration the likelihood of an event happening, the different probabilities, and multiplying it by the valued outcome of those probabilities. So outcomes of whether you win or lose, and if so, how much you lose versus how much you win, or something like that. We had one problem left, and the problem it actually refers to goes back to a question in your textbook. There's a cartoon at the beginning of your textbook in section of this section that talks about the odds against winning the lottery. So the odds against winning the lottery being 55 million to 1. So the first question that we're going to talk about is, what is the probability then, if the odds are 55 million to 1, what is the probability that you would win the lottery? 1 out of what? 55 million. So just for effect, I'm going to actually write it out with all the zeros, okay? It'll help us with our calculation later too. So this is 1 out of 55 million. That's the likelihood you're going to win. Almost. There's one error in what we've done. Do you know what that is? You're really close. We needed to add 1 actually. Remember last time, I know you haven't done any problems on this, so it's probably not something you've thought about since 2 days ago, but remember the way the odds work is that if we had the odds of, say, 2 to 3, this would be equivalent to the probability of 2 to 5. Remember, odds are taking how many chances you win versus how many chances you lose. So if they're telling you that your odds are 55 million, odds against are 55 million to 1, that means one person wins and 55 million people lose, which means the total number of people who played the game or whatever was 55 million 1. You guys with that? Okay, so we actually have 55 million 1 on bottom. All right, part B says if the grand prize is $13,567,290 and a ticket costs $1, is the game fair? So the way that we decide if a game is fair is we calculate the expected value. So the way we calculate the expected value is we look at what possible outcomes can happen. So what does it sound like our options are here? What are there are two things that can happen here. You could lose $1, so that'd be a -1, right? Or you could win. What could you win?
13,567,280. Could you not just kind of like this one? Could you like just look at this one? Because if each person's paying $1, you know it's going to be 13 million, and then if there's 55 million.
So to answer the question, is the game fair, that would be true. If we were asked the question to find the expected value, this is what we would go through.
Okay.
So if I were asking this question, this is actually a question, I think it's straight out of your book pretty much. It may have some different numbers in it or something. If I were asking the question, I would actually ask you specifically what's the expected value, and then ask you, is the game fair based on your expected value? So I'd ask you both.
Okay.
But you're right, yes. I mean, we should be able to sort of look at this and say, 55 million people play the lottery, so forth, this happens. Now, the reality is that there are some lotteries where multiple people win, right? So you can't always just say this means there's 55 million sort of people who play the game. Are you guys with me? Because not all lotteries work this way. Some of the lotteries, and we'll get into this in the next section in 9.5, but some lotteries, the number of chances of winning are simply based on how many numbered ticket options there are. And you may not have everybody purchase each individual number. So it doesn't always work out like what you're suggesting. But it could if we actually sold, for instance, 55 million 1 tickets. Yes. All right, so how likely are you to lose? That's the first one, the -1. How likely is this to happen? $55 million out of 55 million 1, right? And how likely are you to win? Well, that's the first probability that we found, 1 out of 55 million 1. Now, the cool thing is these denominators are actually already the same, so you could just add the numerators together so that you don't have to deal with your calculator and whether it's going to understand the division versus the adding and the ordering and things like that. Sometimes calculators are not particularly user-friendly. I actually have negative 55 million on top. And then this one over here has the 13,567,289 on top. And they can combine because they have the same denominator of 55 million. 1. So you can add those two numerators together in your calculator. And then divide this by 55 million 1. And what kind of answer do you get? What is your answer? It's a dollar amount, by the way.
Negative 1.246. So 25?
I have a different value written down. Did everybody else get this one? I just may have the wrong answer, but she has negative, what was it?
1.246.
1.24. What do you have, Abby? Did you get yours? I think it's negative 0.75. Double check on your multiplication and your addition, or your division and your addition in there, Morgan. Negative 0.75 is what I have written down as well. So if you went and you bought bunches and bunches and bunches of the tickets, on average, for every dollar you played, you would lose 75 cents of that dollar. Like this is the average overall amount. But I want to take this one step further, and I want to talk about what actually happens in real life under these circumstances. This is our last slide. As with many state lotteries, the proceeds are often said to benefit education. Have you ever heard something like that before? Yes, I've heard it before as well. Under these conditions, if all the proceeds benefited education and 1,000 tickets were sold, okay, so this is going back to the question you asked initially, Kinsey, doesn't necessarily mean there's 55 million and one ticket sold. There's 1,000 tickets sold with the conditions in the Part C. What is the expected value generated for education from the lottery sales? All right, so take a look back at our answer to Part B. Part B said, on average, the person who plays the game loses 75 cents every time they play the game. So if they lose the 75 cents, what happens to that 75 cents? In theory, it would go to the education, right, with the premise that we were using in Part C. So that 75 cents, okay. Let's try that again. Oh, it just took my... Okay, we're just going to have to make do. Part C, I don't have the screen. It took my screen away. That 75 cents that was a negative before is now a positive because somebody else is getting that, right? The education department or whatever in theory. And there were 1,000 tickets sold? So it was 1 million tickets sold. Thank you. So if we take our 1 million tickets and we make on average 75 cents per ticket, then how much money does quote unquote education get from this lottery? What does this become? 750,000. And if we had kept our expected value back over here, which was negative 0.75, if we kept it longer, like with the decimals that were actually in your calculator, we multiplied that out, you would actually get 750,332.20. Okay, so this is what it works out to being if you don't round from Part C. Or B, sorry, don't round Part B. You get 332,000. Okay, that's fine. But as you see in your notes, Part 2, or question number 2, it says, Part D, it says, what are the real outcomes that happen? Like, this is sort of the average outcome expected if we ran this lottery billions and billions of times or something, right? The law of large numbers thing. But if we really ran the lottery one time under these conditions, this is not what would happen. All right? One of two things happens. Either everybody plays and everybody loses, or everybody plays and one person wins. Make sense? Okay, so there's two different real outcomes. So outcome 1 is that everyone loses. Okay, well there's 1 million tickets, right? So there's 1 million people who lose, or at least 1 million ticket holders, 1 million tickets that lose. There's 1 million of them. How much did each of them cost? They were $1. So the education department earns $1 for each one of these, which means one option is that the education department actually earns or makes $1 million. So one possibility is that $1 million is kept for the Department of Education by doing the lottery. That's outcome one. Outcome number two is that someone wins, right? So if one person wins, well, we already know that sort of $1,000 was brought in as revenue from the ticket sales, right? But what happens when a person wins? They get money. How much money was it? 13 some odd million, right? So we should take the $1 million that was brought in for education and we should pay them back out the money that they actually earned for winning, which was $13,567,290. So what is that? Right. Now all of a sudden this money-making scheme that was supposed to make education a lot of money costs somebody money, right? The overall problem with this, along with a lot of other things that we sort of tout as good schemes to make money, is that one of two things happens. Either the money's made and everybody loses, which really means why did we sort of play the game, right? If everybody's always going to lose, we could have just made a charitable foundation, everybody could have given the money away. Agreed? The other option then is somebody does win and then the charity or the organization or the whatever that we're supposedly saying we wanted the money to go to either gets nothing or somehow has to come up with the funds to make up for it. This doesn't really work very well, right? But this is the structure of the programs and how they're usually sort of panned out to the public.